Hi, my name is Arun Srinivasa, and I'm the Associate Dean for Student Success at Texas A&M, and also the J.N. Reddy Chair in Applied Mechanics for the Department of Mechanical Engineering. Today, I'm going to talk to you about responsible AI in education, actually mostly engineering education, but nevertheless, I'm going to talk to you broadly about it. Most of us are aware that AI has actually created a Pandora's box with all kinds of things that have come out of it. But those of you who know the story also know that the last item that came out of Pandora's box is hope. And that's what I want to talk to you about. In particular, I'm going to talk to you about how we can go from policing student behavior and worrying about how students are misusing AI to empowering pedagogy and finding practical pathways in AI for learning. Before I start, I wanted to say thank you to two of my mentors, Dr. Jeff Freud, who passed away in 2022. He was the one who introduced me to engineering education research, and I thank him very much for getting me into this kind of area. And my other mentor, Dr. Don Maxwell, who passed away in 2011, he was the one who showed me how to navigate the university administrative system. These two things together are very important if you want to get anything done. For those of you who know how universities work, you will understand what I mean. Please, thank you very much. And that's how I got into this whole area. So this all started with a NSF National Science Foundation project called RED, which is called Revolutionizing Engineering Departments, and through what is called an I-Core project with Texas A&M University. As part of the project, my student Rujan Gao and we interviewed about 120 students, teachers, administrators, teaching assistants, all kinds of people to learn where are the pain points today. And you might recognize many of the pain points. For example, you recognize that it's hard to maintain student engagement and motivation. It's hard to scale pedagogy from small to large classes. This aspect has become even more supercharged with AI, and I'll talk to you about why and what to do about it. It is difficult to provide timely feedback because we have a high workload, all kinds of things are happening. So this is a challenging for us. All these aspects on the left-hand side are very, very critical. Grading homework and quizzes, classroom management, answering student questions, emails, regrading, LMS management, all of these things are extremely time consuming. And the last item is that we know that multiple choice questions are a terrible way to evaluate what students know. They're okay, but they're not very good. But it is very difficult to do anything else as your classroom size gets larger. So this is a huge aspect, and it's generally offloaded to TAs and graders. And you know that, especially if you're grading lab classes, training a TA is very difficult. And once they are trained, you get, they leave, and then you have to retrain everybody. So this is actually a big challenge. But this is not a new challenge. These problems have been more, it has just been exacerbated. The primary problem for teachers is that they are instructors by day and data analysts by night, because you have to sit and look at what your students are doing and all of this stuff. And this is very time consuming, apart from all the other things that you're doing. So you're always short of time. From the student point of view, they have a different problem. They are frustrated because they cannot get the help when they need it. Right? And they do not necessarily know how to get suitable help at the right time. The third one is administrators who have to find support for learners and teachers and all of this stuff, but they're getting ever squeezed with budget. So this basic ecosystem problem is forever. But all of this has been further exacerbated by AI. So let me show you what I mean. AI, most of us became very familiar with the capabilities with ChatGPT in 2022, and then Llama and Fusion and all of these things that happened after that. But it has been around for a long time. I started working on some of this AI-related stuff around 2017 when Transformers came along first, and then worked through all this stuff. We were working with BERT and other things over many years. But one of the things that we have learned over time is that even though it gets increasingly better, the core aspect of it is what is called next token generation. And it just tries to do a probabilistic prediction of the next word. On top of it is what is called reinforced learning with human feedback, RLHF. which provides a kind of intuition to the model. That's why it feels kind of real. So it has two things. It has fabulous memory and fabulous intuition, not necessarily what you and I would recognize as reasoning capabilities. But students have grown up with this technology and they're confusing the fluency of AI with competence, with their own competence. Administrators, teachers, and learners are facing new pressures because of all this AI system, but we are not changing our workflow. We are still trying to say, I want to teach exactly the same way I want to teach. I just want to prevent AI from doing stuff. This is a recipe for failure. AI adoption is rapid, but it's entirely haphazard. And there are challenges of motivation and cognitive offloading. I will talk to you about these kinds of items in this particular thing and what to do about it. Okay, so we've written quite a few papers on many of these subjects because we were trying to explore how AI can be used as help for educators. And we were focused, there's a large body of literature on AI in programming and how well it can do. Programming is a very particular task. Computer science is a very particular kind of task because it's entirely textual. But we wanted to see how well it works when you have multimodal. You have text, you have graph, you have image, and can you reason from images and text and graph and all of that. So we have done quite a bit of work on that. We also wanted to see how good it is with evaluating. So we have written a nice review on automated grading and things like that. Out of this, we produced two practical applications. One is Encando, which is a platform for teachers and learners. It is teacher facing, not learner facing. It is meant to be assistant for teachers. The other one, which is quite important and useful, is the ADA converter. This allows you to convert any document to be American Disabilities Act ready PDF in one click. It can recognize even handwritten stuff. It can recognize anything in PDF form. So what did we learn from our recent studies as of today? So first thing we learned is that, and you may recognize this, that it's great at recall, summary, explaining, and implementing your reasoning and planning. It's great at generating content. Whether correct or not is not the issue, but it generates probabilistic content. This is the worrisome thing. It aims to please, and I'm sure you have noticed that it is because the AI companies are tuning it for engagement, not necessarily learning. This leads to a possibility of dangerous dependence. And this is something that we should keep in mind. And you notice that it's aiming to please also means that it can follow rubrics, but it really lacks conceptual judgment in a fundamental way. And I can, if you're interested, you contact me and I can show you examples of this, what we mean by that. What it is really great at is shallow tasks that requires pulling information from a lot of sources. And that computer coding tasks, because the latter is entirely textual, so it works very well. And it's very, very structured, so it works very well. The former requires not a lot of reasoning, but a lot of collating of information and making sure that they make sense. But it is not great at evaluation of conceptual knowledge. I can show you what I mean by that. It doesn't do well with concept inventories and other questions like that. So you have to be very, very wary of using it for this kind of thing, especially when you get correct but unpopular answers. This is particularly true of what one would call the trick questions in physics. And if there are a lot of correct answers, but they are not very popular, you'll get a problem. And things that require reasoning, if you ask it for its reasoning, many times the reasoning is not correct. And I don't mean that in a casual way. If you ask it for certain proofs, it doesn't do a good job, even though the proofs are available for 100 years or more. It is not great at deep tasks that require specific, detailed physics or non-textual knowledge. So if you get away from textual knowledge, you will see that it will struggle. Of course, all of these things will change rapidly, but its probabilistic answering is a feature and not a bug. So what I mean by that is, one of the problems with this setup is that the same input will not necessarily give you the same output. So you cannot really trust it to give the same answer every time, provided you do the same input. It is extremely hard for it to do that. So keep that in mind. The main thing is to remember is that it can multiply your capabilities, but it's not built to add to your wisdom. What we mean by that is it can be your servant if you're an expert, but your master if you're not. So this is why we wanted to make sure that an AI system is pointing towards the expert and not towards the novice. Okay, so now that we have an idea of what AI can do, let's see how students are using it. One last item, and this is very important. The frontier of AI has fractal boundary. What I mean by that is that this is the reason why for any task that a person says it cannot do, there will be a very close adjacent task that some other person will claim it does fabulously. This is actually because it's at the frontier and there's a fractal boundary. So it is very hard to judge what tasks it can do and what it cannot. But a lot of education tasks are still in the black region. They're not really in the frontiers. So most of the time it is okay, but please be aware of this. Okay, so what are students doing? 90% of students have used it academically. This is from a 2025 report. 75% of reported that their AI use has increased compared to last year. You can see about 50% use it either frequently or regularly. What are they using it for? Brainstorming ideas, drafting outlines, generating initial drafts, writing, rephrasing, all the high-level cognitive tasks, they are using it. And they phrase it as saving time. And you and I know that what it means is that saving time is the same as do my homework. So they are offloading their cognitive tasks to the AI system. This is a huge problem. They are also offloading the tough task of actually gaining foundational knowledge. It's understanding complex topics, is gaining foundational knowledge. That is being offloaded. Ability to come up with new ideas is being offloaded. All of these things are problematic. You can see that the ask copy workflow is replacing think, do, diagnose cycle. So you can see that people are using it for searching, understanding, reading, writing, critical thinking. You can see that that's a huge of interest, stimulating creativity, So this is a huge problem. So what does it lead to is that this is challenge for educating the next generation of students. And by the way, many AI tools tend to decrease student cognitive ability because the corporations and business leaders fundamentally misunderstand what is education. So you can go to NotebookLM, for example, and it will do a mind map if you give it data, and they think, oh, this is useful for teaching or for learning. It's actually not. It is not the mind map. It is the creation of the mind map that helps you learn. So if that part is done by a LLM, you will not learn it. So the mind map is not useful for you. So that's what I mean when I say that this is an issue. So for effective learning, we know the Bloom's taxonomy stages. You remember, you remember the basic stages: remembering, then understanding, then applying, then creating, evaluating, analyzing. This is not meant to be sequential, but you have to understand that you cannot do the top level without also being able to do the bottom level. What happens with AI systems is that the bottom level is just being replaced by the students and even some of the top level stuff. This is going to create a massive problem, which is called cognitive debt. So this was a recent study from MIT where they asked students to do a fairly straightforward task. Write an essay. One group was allowed to use a large language model. Another group was allowed to use a search engine, and the other one was allowed to use a brain. So you can see red, green, and blue. After 1 week, they asked the students, what can you remember from whatever you have written? 80% of students who wrote their project using large language models could not remember even one item. They could not quote anything from what they have written. This is cognitive debt. It is actually passed directly from the AI system to the document. So this, I'm sure you know, but the effect of it is devastating. So what is happening is that the effort is the algorithm for learning. What I mean by that is, you can see a picture of a construction site. You can see all these trucks and other things. They are able to, I mean, forklifts, they can lift large amounts of weights because that is needed for construction. So in a construction site, the forklift is extremely useful. But imagine if you think that the purpose of going to a gym is to lift weights, then the correct thing to do is to bring a forklift because it can lift much more weight than a person. This is what students think our classes are like because of the way in which we are evaluating them. So what happens is they think, okay, your task, your job is to complete a task, not to go through the process. So what happens is that they are bringing the forklift to the gym. We are a mental gym. Our aim is to develop specific brain skills, brain cells by doing the tasks, not completion of the task. But our evaluation is based on task completion. That is really at the heart of some of our difficulties. What this leads to is what is called a hollowed out senior engineer. They are actually just a verbal voice conduit for an AI system. That's all. So the reason for this is in my mother tongue, which is Kannada, there's a saying which says your leg aches when you see a horse. So you can see this person waiting at the elevator to just go one floor, even though there's a set of stairs right next to it, and you can see that students will wait, or not just students, everybody will wait 5 minutes for a lift or elevator just to go one floor. This is what happens, and then the more sensible among them will realize that this is bad for their legs and they start climbing the stairs. This is what is the problem. So I'll show you how this maps on to what happens with AI. So I'm going to list a bunch of skill areas, what AI can do, and therefore what kind of loss of competence it leads to. So for example, if you give them a project, it's a cold start. So students don't know what to do and they fear it. So they go to the AI generation and it will generate some text. But students will quickly lose the capability for need analysis and planning abilities. Okay, converting a blank sheet of paper into a plan is a critical skill. Task breakdown is the second one, which means that how can I break up a task into multiple pieces? AI is very good at this. So students will just use this, which means that they will lose the competence for task organization. Debugging diagnostics is frustrating and time consuming, whether it's a machine or a computer code. For computer programs and some math problems, this is AI strength. You cannot compete with it on this. But what happens is that you do not learn from failure. You have lost the capacity, and you know that the common statement, that failure is a stepping stone for success. Now you have a problem because people are not failing; they're just asking the AI to do it. The last one, this is a very very thought-provoking item. Many people and corporations particularly think that AI is great at explaining, so you can get it to explain. But you and I know that when you are teaching is when you learn. It is the construction of the explanation, not the explanation itself, that enables you to learn. So if you outsource that construction of explanation, you will get illusion of competence. I'm sure like many of you, I have watched, let's say, carpentry videos or something like that, or even math videos. And I think I understand it until I try to explain it to somebody else. So this is a huge problem. The question is, what is it that we can do about it? So let's look at what is it that we are actually trying to do. We need to move from exposure to content to competency development. As an instructor, I need to decide what should I make them do, not what topic to cover. What competencies am I seeking to develop, and at what level? This list of competencies is really critical, and levels, by the way. Then I have to answer, how do I make them do it rather than offshoring it? There's something called a 7E framework. I'll talk to you about it. There's one possibility to think about it. And you have to divide the activities into formative and summative activities. Formative activities, I've listed them. So I will go through them in a quick way in the next slides. So you will see how this works. And then how am I assessing whether they have done it? Formative assessment should assess process, not just task completion. And assessing process is very difficult. That's why we just look at it and say, okay, fill in the bubble, do a multiple choice, and assess your task completion. And this does not encourage learning effort, but we need to encourage that. Summative assessments are different. They should demonstrate learning outcomes in a verifiable way. There's a way to do it if you want. I mean, I'm not going to talk about it, but it's well worth for you to investigate. This is called rubric-based analytical grading. This is how you need to grade, but this is difficult to implement. So these are challenges. And by the way, those of us who have used, Connects or one of these things from McGraw-Hill and other book companies, their automatic graders are terrible and they are detrimental to learning. The book companies know it, but they are offering it because we are using it. And we are using it because the book companies are offering. You see the catch-22 there, right? So this is a huge problem. So in order to figure this out, what do I mean by competencies? Let's look at again this Bloom's taxonomy. On this side, I'm going to kind of match it with competencies. The lowest level competency is called a novice, and a novice is somebody who can follow an instruction. So they are the person who will smell the dish burning in the oven, but it says 20 minutes in the cookbook, so they're going to wait for 20 minutes. An advanced beginner is somebody who can do a little bit of closed loop. They can look at it and they can see, oh, the dish is burning, so I got to turn off the oven. Right? They can understand and adjust the algorithm based on the outcome. So if you want somebody to be at that level, you have to ask questions like that. Competent means that they can plan a process given the task. Which means that these are the people who know that you should make the cold food first and make the hot food later for a party so that the hot food is hot. Proficient is somebody who knows how to organize the party. So now you can see that I can do task planning given goal. Right? Then you come to the next level. Expert is somebody who develops goals from vaguely defined items. This is so if we have an idea of what level we want, then we can correspondingly ask questions. Most of the disagreements in an engineering class are because we don't really talk about level. We only talk about content. Okay, so let's see how to do this. The first item is we need to make sure that our students have foundational knowledge and reasoning, which means they should be able to question my answers and not just answer my questions. Then our problem should have real world context because idealization is the real task, not just computation. Representational competence means that you can move between different representations of the same object. So it could be graphical, symbolic, and pictorial representation. And you can see this is what we mean by when we say our students don't know how to interpret the result. What we mean is my symbolic representation tells me that the force is 20 newtons. When I convert it into the physical world, I have to figure out whether it's too much or too little. That's what I mean by moving between different representations. Planning and organizing, not just following algorithms. This is a very critical skill. Separation of functionality and implementation. So they have to understand what is the concept and what's the algorithm. The algorithm may be different, although the concept may be the same. So they have to understand the difference between these two things. The next thing is iterative innovation with reflection and feedback. This is metacognition. Focus on what you learned, not just the result. So when you do a process, you ask yourself, what did I learn from this? Rather than did I complete my task? Last thing is collaboration across disciplines. This can only happen if you have foundational knowledge and if you understand you have representational competence and other things. So this is why it is in the lower part of this thing, because it requires all the others in order to do. The last one is very, very important, learning how to write specifications, which means that do they know what is the real need? What are the constraints of the problem? What steps are you going to take to verify what you got? What steps are you going to take to validate what you got? What are the indicators of success? How are people going to use this? Right? This is what, if you're able to do this, even if you're using a LLM, you are in control because you know what are the needs, you know what are the constraints, you know what is necessary for verification, and the AI system is only your servant. So what does it mean for teaching and assessments? Number one is you have to move many of the cognitive tasks into class activities. So what I mean by that is, in my class, the planning part of it. So when I give people homework, at the end of the day, I ask them, okay, sit down and let us plan each of the problems. How are we going to tackle them? So we have moved the planning part to the class so that students can discuss, learn the plan, and then they can go and implement. But they have done the planning in class because that is very important. Don't give them pre-digested problems, give them real world context. So this real world context can overwhelm people. That's where your level comes in. If you know that I want a real world context at the level of a novice, I'll give one kind of problem. If I want a real world context at the real level of an expert, I'll give a different kind of problem. So this is where you have to know whether you're trying to train at a novice level, expert level, what level. And the key is reasoning from first principles, not rote repetition. Couple purely analytical cognitive tasks with some design decision activity. The way I put it is make it to learn it. So students should be able to actually make physical representations of their objects, not just to do everything on a computer. This is very critical. So there's a difference between somebody who knows plumbing versus somebody who took a fluid mechanics class. People should know both, or at least fluid mechanics in the context of plumbing, or plumbing in the context of fluid mechanics. Pick whichever way. This is very important. Teach representational competence, which means evaluation, judgment, not just algorithm following. Again, this you have to do in class because this is again something that can easily be done by AI. You want the students to be able to do that in class. And I keep mentioning this thing, our textbook problems are all obsolete. So what I mean by that is I teach a statics class. Actually, I have this, the real problem is a snowed-in roof, not this idealized truss with snow load. So I always ask my students, you go outside and you look at it and show me any force arrow. There is no force arrow. This is something the students have to learn. How do you do this? So the first step is to have some kind of framework so that you have a consistent way of doing. I am showing you a particular framework. This is called the 7E framework. So what you do is you start by assessing prior knowledge. Don't start with a concept. Start with figuring out what students already know and where are the students, where are the students misunderstandings and so on. And this is the place to engage the students. If you miss this, then you'll have sleepy students. Once you engage them, allow them to explore and then follow it up with an explanation. That's the second stage. Then you come to the third stage where you have to evaluate. You have to look at how these things are done and so on. And the fourth one is elaborate and extend. So you can ask them to extend it to real world situations and so on. This process is called 7E. You can see that there are 7. And if you do this in a systematic way, your approach to pedagogy will be systematic and predictable, and it is easy for you to see which part you missed. And in class, you can see how this maps to what we want. What we want are engaged students. What we have are sleepy students. So we need help with that engagement. We need help with formative feedback. especially for lab reports and project reports and other things, students actually need to get some feedback before they give you the final report. And this is hard to do because you cannot regrade multiple times. What we do is summative, and this is why the students are bringing forklift to the gym. What we want are some level of open-ended questions, because this takes, but unfortunately, most of the time we do closed-ended questions because they're easy to do. So how do you do that? You need an AI native teaching workflow infrastructure. That's what that's what we built. You need to reclaim pedagogy. So what is the idea behind what we have built? It is an AI portal to improve your effectiveness and time in teaching through responsible automation. This is facing you. It is your assistant, not the student's assistant, not a tutor. Core principle for how we built it is very simple. Whatever task you give the students will do only what is inspected, not what is expected. So if you're going to give them a task, you have to find a way to inspect, and this is where we get killed. So this is what we are trying to automate. For example, if you have learning materials and things like that, the AI system will help you organize it. It will help you do readiness assessment for students, because if you ask students to read the learning materials, that's what you expect them to do. But unless you inspect it, they won't do. So that is where you get readiness assessment. The AI system will easily assess the students for readiness. This is a very useful one. Generation of quizzes, homeworks based on your notes and concepts, and also a world exam. Many times you have a format for your homeworks and quizzes. You want to generate new ones. This is very easy to do. Project report feedback based on your rubric. Again, this is not grading. This is just feedback to students so that they can go and improve their work they're writing. It can grade homework based on your rubrics, but not just grading answers. It will grade their process. Right? So this is very useful, especially if you want them to redo until they get it right. Research back lesson plans. So one of the items is the 7E that I talked about. If you have an idea of what you want to teach and you have your notes, it will help you generate a lesson plan based on the 7E framework. And last, all of us know that with accreditation organizations like ABET and other things, it is like pulling teeth without Novocaine and generating reports from your class. This is a piece of cake. So these are the items that it can do. But please remember, any AI system will also do only what is inspected, not what is expected, which means that it requires expert supervision. The way to think about it is that you are the surgeon, it is your nurse assistant. It is great at routine tasks, it is great at having a good manner, all of that, but you get to decide what medicine should be given, what operation should be done. I'll show you a demo of this tool that I talked to you about. If you want more information, it's on the screen. You can contact Rujun at encando.ai or me. This is a startup by my student, Dr. Rujun Gao, and it's in College Station, Texas. It's a spin-off from my NSF project and went through the NSF iCore. The IP is owned by Tamu and is supported by Tamu Innovations. I am a co-founder and my participation has been approved by the Board of Regents of Tamu. So this is what the portal looks like. You can upload your notes. You can see that there are these tiles, and here's an example of some notes by my partner and friend, Dr. Krishna Narayanan, who is a partner in this company. And you can see that he has something on Euler's formula written up there. But the main thing about this is it will organize all your material, videos, PowerPoint, PDF, whatever you want, you can stick it in. And also it will generate readiness assessment, and it'll also allow you to interact with the video. The student can ask questions about any timestamp in the video, it will explain. You can do research-based lesson plans. You can see I'm doing a lesson plan on balance laws or something like that. Doesn't matter what it is, but it will start doing what are the learning goals, what are the things that you need to do for the 7E. You can see the elicit and other things. So what it will do is it will generate lesson plans for any topic. that is grounded in your notes. It can generate quiz, homeworks, that kind of thing. You can create all kinds of different types of quizzes. You can generate any kind of quiz. You can say, I want similar items, that kind of thing. So it's fabulous for doing this. You can deploy from generated quizzes. So you can pick any number. You can also do randomized, all kinds of things are possible. It can generate practice quizzes for students at any level. You can test your knowledge with 10 randomly selected questions from this course. You can select the chapter. So this is a great way for you to prepare for exams and things like that. It provides feedback for notes and reports. If you upload your rubric and the student uploads their project, it will give them some feedback on what was good, what was bad, and so on. So you can do fairly, every stage at the reporting, you can do something. It will scaffold the student for writing better reports through multiple routes. So for example, you can say, upload an outline for me, and you have to evaluate the outline. Then you can do other things. So even if the students are using AI for generating outlines and so on, they still have to generate every step. And it will prevent just AI generated slop. It can grade your homework. And by grade, I mean it can be your grading assistant. So let us be very careful. It is not automatically grading everything and you don't see it. But it does do a decent job of identifying where are the mistakes. So for example, it has complete capability to return handwritten text. And it will actually generate a rubric. You can go and modify the rubric. So the rubric allows you to be uniform in your grading across any number of people. You can do triaging by looking at only those people who got low scores to see where they got wrong. All of these things are possible. Okay, it has no difficulty with comprehending handwritten notes also. All of them are integrated in one platform so that you don't have to go to different places. It keeps all that information. It can do auto grading, and it is really quite good. You should try it out if you're interested. The current chatbots as of now are sycophantic and tuned for engagement, not learning. Very similar to Facebook, built to remove effort and get answer. This is detrimental to learning. Students are using this extensively. Indiscriminate use is like bringing a forklift to the gym. AI capabilities are leading to cognitive decline, leading to hollowed out graduates with illusion of competence. Faculty need to focus on competency development rather than exposure to content. And we need to inculcate a design and critical thinking mentality by continuously evaluating process, not just outcome. But without substantial help, this is very time consuming and costly. ncandoco.com actually can do that for you. But this is just, of course, it's the platform that I built, so I'm talking to you about it. But there are others if you're interested. But I happen to think that this is the best, but that's because we built it. Okay. And if you are interested in playing around with this, contact Rujun at nkando.com or go to the nkando.com website for trial, demo on trial. Thank you very much. I don't know.